So guys, now let us take one more example. Suppose we want to do a route lookup for the IP address 1.2.3.5. So convert this IP address into its equivalent binary form, take up the stack, and we will going to start our search from the root node. So the don't care child of the root node is 4. So just push the entry into the stack. The node number is 4 and the total number of bits of the input that has been passed is 0. So here 0 means the beginning of this input string. So now let us begin our search from the root of this mtry data structure. The first bit of the input binary string is 0. So we will take the path along the 0th child of the root node and we land at node number 2. The prefix length of the node number 2 is 8, so we will going to match the 8 bits of the input string with the 8 bits of the effective prefix of the node 2, and they matches. So because they matches, therefore push the don't care children of the node 2 into the stack, which is the node number 10, and the total number of bits that have been successfully passed is 8. Alright? And we will continue our search. So the next bit of the input string is 0, so we will take the path along the 0th child of the node 2 and we will land at the node number 9. The prefix length of the node number 9 is 24, therefore match the 24 bits of the effective prefix of the node 9 with the 24 bits of the input string. And sadly they do not matches. Now because they do not matches, therefore we will going to shift our search from node 9 to node 10 by popping the top element from the stack. The top element from the stack says resume your search from the node number 10 and the total number of bits of the input string that has been passed is 8. Alright, so we are at this bit position in our input string and we are at the node number 10. Now prefix length of the node number 10 is 24, therefore match the bits of the effective prefix of the node 10 with the 24 bits of the input string and they matches. Alright, because the effective prefix of the node 10 is all don't care, therefore node 10 matches. And now after this match, the total number of bits of our input string has been exhausted, therefore we stop our search here at node number 10. So the route of interest that we are looking for is the route 1.0.0.0/8. So this is the route which will be used by our router in order to forward the traffic which is destined for IP address 1.2.3.5. In other words, we say that this is the route which matches best with this IP address as per the longest prefix match principle. And of course, once the route is located successfully in this route lookup algorithm, we will destroy our stack. Now note that as long as in your mtry data structure you have this default route installed, so it is not possible that for a given any random IP address, if you could not find the route as per the longest prefix match principle, then at the least the default route 0/0 will going to match with any random IP address as per the longest prefix match principle. The node number 4 is the bottommost point in the stack, and when this will pop out of the stack, you will shift your search to node number 4. And when you shift your search to node number 4, the effective prefix of the node number 4 is all don't care. So it means that whatever your IP address is, it will certainly going to match with this route, which is 0/0. We actually call this route with a special name called default route. So this was the IP route lookup algorithm. You may practice it more for different IP addresses and try to look up those IP addresses in this mtry data structure. So I leave it to you to practice yourself. So now let us summarize what we have learned in this course so far. We learned the data structure called mtry, which is a tree-like structure. Each node is a prefix of its children. Alright, so just like you have a name, let's say Abhishek Sharma. So Abhishek will go in the parent and Sharma will go in the child, or something like that, such that each node contains the data which is a prefix of its children. This is the property of this M-trie data structure. And for this reason, the trie families of data structure is also called prefix tree. Alright, they are also called prefix tree because each node contains the prefix of its children. In other words, every children contains the suffix of its parent. And we learned about the route insertion algorithm, route search algorithm, route lookup algorithm, and route deletion algorithm. All of them takes order of k time, where k is the number of bits in the input string. So for IPv4 address, k is equal to 32. So essentially, M-trie data structure gives you constant time complexity.